Hello everyone, welcome back. So in the last class we started with elliptic curve cryptography. I have told you how this elliptic curve is a group of uh, new group or under the operation it is actually a Abelian group under the binary operation addition. Let me just quickly recall what is the elliptic curve cryptography. First of all, I am defining a elliptic curve, that is equation y square equal to x cube plus ax plus b on the field f. Then EAB is the notation which we are using, and how this forms addition. So I am having this infinity which is called identity element with respect to addition. So if I'm adding p plus minus p, I'll be getting identity. And suppose I'm having p, then minus p is what? X comma minus y1. And I am having q. Suppose p and q are the 2 points. Q is not equal to minus p, then p plus q is x3 comma minus y3, and is defined as x3 is equal to lambda square minus x1 minus y2. Y3 is lambda x3 plus c, and this c can be written, you can substitute it, you'll get a nice form. And this is what lambda is. If the points are distinct, then we can find the slope. If the points are same, then we'll find that slope of tangent, because in that case I'll be having a tangent. So generally what happens, suppose p and q are given, I have to draw the straight line L, and this L will cut at a point R. Then I'll just take the image here on the parallel to x-axis, image of R here. This will be your R dash, which is p plus q. And yeah, then we have found out the x3 and y3, correct? So the point at infinity, actually the point at infinity is actually in the form of x comma infinity. So and its inverse image is also x comma infinity. That means we are considering negative of infinity as infinity. Okay, then add and double method for point multiplication. How do you multiply? Suppose I want to multiply 2 points p and q, then we can use it with addition and double multiplication, double method. Add and double method for point multiplication. Similar to square and multiply method, we use add and double method in elliptic curve multiplication. For example, suppose I want to find 18p, that in 18 is multiplied with p. So what I can do, we do the doubling and one addition. We do 4 doubling and one addition. That means what? This 18p, what I will do, 2p plus 2 times 2 times 2 times 2p. So first doubling is 2p, then whatever 2p I am getting, I'll double it. It will be 2 times 2p, then whatever I am getting, I'll double it, and then again I'll double it. So this is what I am having. I'll got 16p, then I'll add it with 2p. So what I am got, I got 18p. So it is multiple point multiplier. A number is multiplied with the point p. So this technique will be used later on in the elliptic curve. Now let us come to elliptic curve crypto system. The crypto system based on DLP and factoring problem over Zn star can be generalized to elliptic curve. Elliptic curve, for example, ECDHP, Diffie-Hellman protocol, ELGamal, ECRSA, ECDSA. DSA will be learning later on, digital signature standard algorithm, or etc. So this ECC based DLP is more popular and more powerful, more useful than ECC based factoring. Okay, so now let us see ECDHP. Elliptic curve Diffie-Hellman protocol. Okay, let G be a cyclic group. Cyclic subgroup of an elliptic curve say EP of AB of order n. Let P is equal to x comma y be a generator of G. Suppose Alice and Bob want to share a secret key K. Suppose Alice and Bob want to share a secret key K which belongs to EPAB. They proceed as follows. They proceed as follows. So suppose I'm having Alice here and this is Bob. So as in Diffie-Hellman protocol, it is quite similar to that. Alice chooses DA. He'll choose a DA belongs to Zn star and compute K1. Compute K1. What is K1 actually? DA multiplied with P in EPAB. That is this D is a number which is multiplied with P. So this DA is my secret. Okay. Similarly, Bob do He has his secret db belongs to zn star, and compute k2. What is k2 actually? db multiplied with p belongs to EPAB. So as in Diffie-Hellman protocol, this K1 he sent it to Bob, and then Bob sent K2 to him. So after receiving this K1, what he does, he can get the key. Let me call it as key. He will just multiply his DA with the received value. So DA is multiplied with K2. Here he will do K is dB is multiplied with K1. So what is the key? DA P. Here the key is same DA P. So they got the same key. This is what Diffie-Hellman, elliptic curve Diffie-Hellman protocol. Yeah. So the security of the above ECDHP is based on elliptic curve DLP. ECDLP. Okay, yeah. And yeah, if I have not mentioned what is ECDLP, suppose I'm having k is equal to some p times or some a times p, some a times p I'm having. So given p and k, can you find the value of a? This is what DLP problem is. Given p and k, can you find a? Okay. Yeah. So this was your ECDLP. Let us do one more. That is elliptic curve based ElGamal crypto system. Elliptic curve based ElGamal okay. Yeah, so suppose Bob wants to generate keys for, let me call this as ECLGamal. For ECLGamal crypto system, he proceeds as follows. First is key generation. There are some steps in key generation. First is Bob chooses an elliptic curve EPAB. Let me stop putting point. Yeah, choose EPAB over FP. So he got the elliptic curve. Choose a point P. Choose a point P. This is capital P, which is x1 y1 belonging to EPAB of order NC. That means n into P is infinity, or point at infinity. Okay, then what? He randomly choose D. randomly choose D belongs to Zn and computes Q is equal to D cross P, that multiplication dp. Let me call it as x2 comma y2. Okay, and then Bob announces this is public key. Let me call directly as public key. Public key is what? EPAB, the curve P and Q as his public key, and D is his secret key. Secret key is D. Okay, now let us see encryption. So suppose a plain text M, say M is there, x comma y, sorry, M equal to x comma y is the plain text. And you want to send this M, correct? So he will, suppose Alice is there, so she will first choose a random, chooses a random integer R and computes C1 equal to RP and C2 is equal to M plus RQ. Okay, and the ciphertext is C1 comma C2, as in the case of ElGamal crypto system. Now for decryption is easy. Bob first compute C. First compute C, which is say D comma C1. So I am multiplying D with C1. So I'll be getting what? I'll be having RDP. Okay. Then compute the plain text. M can be computed just by C2 minus C, because this RQ is what? RDQ. Q was DP. So it is M plus RQ minus RDP, that is M. Yeah. So we can compare advantage, disadvantage of ECC over RSA also. The main advantage of ECC is that it provides the same security level with smaller key size. Due to smaller key size, the encryption process becomes faster and requires less computing power than RSA. For example, ECC with 160-bit encryption key provide the same security as RSA. Yeah, this is the important point. ECC with 160-bit encryption key provides the same security as RSA with 1024-bit. And depending upon the implemented platform, ECC can be around 15 times faster than RSA. And depending upon the implemented platform, ECC can be around 15 times faster than RSA. Now let us talk about disadvantage. One of the main disadvantage of ECC over RSA is message expansion. The plain text and ciphertext size in RSA are same, but in ECC the ciphertext size is twice of the plain text size. The size of the ECC is significantly more than RSA. And ECC is actually more complex and more difficult to implement, whereas RSA is very simple. Yeah. Okay, thank you so much. We'll stop here. The next class we'll start with digital signatures.